Hi guys, today I just going to start my new project is the laser engraving machine. So this is my final design. I think I might make some mistake, just I will realize later when I assemble the machine together. But let's just continue. This is the linear bearing. Just I show you in my last video the design. Just it's more symmetrical and easier to put together. But one of the viewers just told me one very valid point. Just this version might have less stability in the rotational orientation here. For this problem, I don't think that I need to be concerned on the y-axis here because it have this bar to stop it from rotating. But on the x-axis, it might be a problem just make the machine less stable. So I might need to put more skate bearing here instead of one only in the middle of the rail. I'm going to put two each one on like close to the edge of this tube, so it's going to be more stable on the rotational orientation, and it will work the same in this orientation like linear side. So that part I don't think I need to show you how to do it because I already show you in the first version. I just going to have three spacer here instead of two, so just to space out these two bearing like from here on this side and another one on this side, so it's going to be easy. Okay, and the next step is just I have to trim the aluminum square tube to equal length. These two need to be the same length and these three will be the same length, but to make it easy I just going to cut all five of them to the same length. So I will show you my trick to do that. Okay guys, so I have here 6 pieces of aluminum square tube which I bought from the hardware store. They are roughly about 25-inch length. They're not exactly the same though, because you can see that here it's not exactly the same on both sides. So what I'm going to do is that I have to trim them to the exact same length. So to do that, first of all I'm just going to tape them together so they don't move when I cut them. So I'm just going to use some masking tape here. Just tape them really tightly together. Okay, so now I just going to make sure that it is well fixed here. Just I'm going to trim a little bit just on the edge. Make sure that it will cut through all the tube. So I'm going to do it like this, and I'm just going to use a C clamp to fix it down so it doesn't move. And to cut this, I'm just going to use some of the abrasive blade instead of the teeth one. It will cut more smoothly and safer. Okay, finally it's done. It cuts through. So I have this one is flat, this end's flat. So they're supposed to be exactly the same length. I only need 5, but I just have one spare piece just in case I make some mistake when I drill the holes. Okay guys, so now I have all the tube here that trimmed to the same length. So the next step is just I have to drill the holes here. Just going to have to line up with the hole on the corner bracket. Look from the bottom here. Just you will see that yes, the hole here. So I'm going to use some M5 bolts. Just go through this hole and lock this with these tubes. So at first I think just I'm going to drill the holes at the size of like 5 mm, so the bolt will go through, and I use the nuts just to lock the bolt and the tube here. But I think just if I squeeze, like turn the nuts too tight, the tube will be kind of like deformed and not going to be squared anymore. So what I'm going to do is just I drill the holes here with a 4 mm bit, and then I'm going to make the thread using the M5 tabs, and then I can just lock it down using the M5 screw. Goes from the bottom and lock it with the thread I'm going to create here. Normally what people do is just they got to mark the holes, like the where to drill it, and use the drill to just like drill there. But I don't really trust my hand. Even if I mark the hole, my drill bit might just like slide and slip. So what I'm going to do is just I'm going to use the CNC machine to drill the holes, and I'm going to use 4 mm bit. So then I'm going to use the M5 tab to make the thread. So to do that consistently on all the tubes, I think I will have to design some type of fixture so I can swap out the tubes more easily and consistently every time. So let me just design that fixture first. Okay, so here the fixtures that I designed. I have the slot here, just is long enough I think for the tube not going to move like sideways. And then I have the on the bottom here some slot that I going to slide some M6 nut in, and the hole will go through, so I can use the bolts go through this and lock with the nuts down here, and some bar to go across to lock the tube down, so it's not going to move up and down. So that way it will stay in place, and then I can just slide the tube in, lock it down, drill the holes, so it will be like kind of stable every time, and the same like on all the tube. So let me just show you how to set up the milling of this in Fusion 360. I think just I only show you the setup, like Fusion 360 setup only on this one. All the other parts will be kind of the same, and I don't want to make you bored with the process. If you have difficulties on any parts, just let me know. I might just post some videos to support this process, but I think just it will be easy. So let me just show you this part very quickly. Okay, so here in Fusion 360, what I'm going to do is just I'm going to open the port. Just click on open from my computer, and I'm going to choose the aluminum tube fixture for drilling. So I just click on that. Okay, so now this is imported. What I'm going to do is just I'm going to actually mill the bottom first, like those slots, and the holes go through here. The reason is just after I mill this, put in the nuts, and then I will flip it over here, and then just really fix this piece down so it's not going to move. Even like I slide in the tube and things to fix it the tube down, so I have to do it a few times. So I don't want this stock to move. That way, once this like milled, it will be like always parallel to the y-axis, so it's not going to move, and it will be consistent every on all the tubes. So let me just flip it over to mill the bottom first. So just click on this, move and copy to the middle here. No, wrong point. Okay, right here. I'm going to rotate in a Y angle 180 degree. Okay, so now it's flipped. I'm going to just go to design, manufacture, and then define the stock. Okay, so just click on setup and choose the box point. I'm going to choose this one in the middle here, and on this edge. Okay, go to stock. I'm going to put side offset about 5 mm. Probably no, I actually don't need to. I put 0 and 0. So I click OK. Okay, so next step I just going to go to 3D pocket clearing and select the tool. I'm going to choose the 3mm flat end mill for this one. Okay, and then well, I don't have this, and well, I don't need to choose anything because I just leave it bounding box. It actually going to find the pocket by itself, so I just leave this like this, and here put 4 2 so it go a bit faster. This I'm going to actually drill all the way through, so I could put minus 0.4mm, and tolerance I'm going to put a bit more precise. I don't leave any stock. And to do shortest path, well, that's it. I click OK. Okay, so I think it's correct. Well, let's just check carefully. So it drill all the way through, and here it do like the hexagon here. So everything seems to be fine. So I'm just going to export this, post process, post. So here what I'm going to save it in the folder. So I'm going to put alim tip fixture bottom. Okay, so now the file is saved. What I'm going to do just I'm going to click press Ctrl Z a few times, so it go back to the original position here. Okay, so it face up. So now I just go back to manufacture and create the setup, and I choose the same point here. Then I go to stock, I put also the same and click OK. Now I also just only need to clear out this pocket. So once you set this up like on the platform, just make sure it doesn't move, like it really stay in place. It had to be stable, so all the tube when you drill it, it will be exactly at the same place. So I just go to 3D pocket clearing again, and then well, select the tool. Actually this one I'm going to use the 6mm flat end mill because I make it a bit faster, so I click OK. And this one I might just reduce the speed a bit, make it cut a bit smoother. Bounding box. Okay, so actually this one I'm going to do selection, and tool center is inside the boundary, and I'm going to do -6 extra offset. You're going to cut it all the way out here, so it will be like cut everything at the edge here. And next step, well, I put 4 2. This I don't need to change anything. I also make it a bit more precise, nothing to leave, and shortest path. I'm going to click OK. Okay, it look correct. It's going to just mill all the pocket here. So now what I need to do is just export it and go downstairs to mill this. Okay, I'm going to put it top. Okay guys, so to mill this fixture I just going to use this scrap piece of wood. So it's the size of it is about like 30 centimeter length, and well, as long as it is more than centimeter width, it will be fine. So I just going to line it around here, so that way when I push the tube, it will be, I will have enough space here. So let me just fix this down, mill the slot for the M6 nuts first, and then I will flip it over. So let's just fix it here. Okay, so now you have the slot just mute. You just take some of the M6 nuts here, just pound it into the slot so it's sink inside. I'm just going to take it on the floor and pound it in. Okay, as you can see here, I pound in the nuts. It's not that hard. It's kind of like fit tightly in here. Just the same way just I make my wasteboard here. So I just flip it over, and now just need to check if the bolt can just slide through and lock with the nuts underneath. Yeah, all the holes, it will be easy. So you can just you can see it just goes through very easily. So this way I can use the same setup here to lock the aluminum tube down. So next step, I'm just going to fix it here again. I'm going to move the slot here. So this time we need to really fix it in place so it doesn't move at all when I push the tube inside. And I will need to have enough space at the front, so it should be around here. Okay, so now I just want to really tighten it. Use a lot of this type of setup to fix it down and push on the side, so make sure that it doesn't move anywhere. Okay, so now I just tried it on different tubes, and they all slide in very snugly and easy to put in. So the size of the slot is good now, so I just going to use this fixture to drill the hole. So let's just move on to the next step. Okay, so now I have the fixture ready. I just going to leave it on this setup until I am done drilling all the holes on all the tubes. So first of all, I just have to fix a tube here. Just slide it in. It's not very tightly. You can just press it down all the way in this way and down. And now you can fix it down using this setup. Just have the screw down here. Okay, so now the tube is really tight in place. It's not going to move anywhere. Okay, the next step is very important also. Just you have to make sure that you have your touch properly set up and all the edge filing script is set up on your CNC. So you can find this corner. So you can just kind of drill it precisely right in the middle of the two holes that you need to drill. So to do this, I just use one of the broken bits that I have before, 4mm shank. I mean, precisely it is 3.96mm. So I just slide it in here and tighten it. Okay, one thing is very basic mistake that I made. I forgot to kind of like clamp the probe here and put it here, so it was almost crashing and breaking things. Lucky I stopped it soon enough. So don't make that mistake. Make sure that you clamp your probe and make it touch the tube. Okay, so now this corner is found. What I'm going to use to drill the hole is this 4mm drill bit. So I'm just going to put it in. Okay, so now you have the tip of the tool is propped to the surface of this tube. I'm just going to show you how to set up the drill of the two holes right in the middle of this tube on Fusion 360. Okay, so here in Fusion 360, I just going to open the aluminum tube. Okay, so I only need to go to manufacture and create the setup. So the box point I'm going to choose this point is where I use the tool probe to find the corner, and this I put 0 and 0. Okay, and I just click on drill, and here I choose the tool. I already create the 4mm drill bit here, so I click OK and disable this. I'm going to go very fast. I go 10,000 for the spindle speed, and plunge rate I'm going to go very slow, 4mm per minute. So to drill through this is about 3mm, so it's almost 1 minute per hole. It's not too slow. And here I'm going to just click on the hole that I need to drill here, and that's it. I go here, don't need to retract too much, and this one I put 0.5, and offset here. Well, I first going to check this because I want the drill tip to go all the way through the bottom, and here I put -1 to make sure that it go drill through. So like this, you're going to go through because the edge here is about 1/8 of an inch, 3.1mm. So that's it. I click OK. Okay, so now the drill is set up. Let me just show you how it drilled downstairs. Now I have all the tubes drilled with the same way, so the holes are at the same position. Next step is just I'm going to start to mill all the other parts, especially the corner bracket, to make sure that the holes are lined up. And I also have to make the thread on this. Okay guys, so while I'm waiting for the corner bracket to be milled, I'm just going to make the thread on those holes, and then I'm going to use the M5 bolt 08mm pitch to test the thread. So I have the M5 08 tab here, so just going to do one by one. So first of all, I'm just going to put some oil, cutting oil on it, on the hole, around the hole. Well, I put too much, but you don't need it that much. You just need a little bit, so I just spread it to the other hole. Okay. Then, well, just step firmly on it, and then just. So you don't need to go high speed, just go actually pretty low, so it will go through. And when it's bike, it just like pull it down by itself. Wow, perfect. So now the thread is done on this hole, so I just make on all the other holes. Okay guys, so last time after threading all the holes with the M5 tab, I found out that some of the holes just the screw just like slide through the thread without any kind of friction and stuff, so the thread wouldn't cut well. So what I did is just I had to run outside and buy a new set of tab that is a lot better, and I make the holes bigger, and I use the M8 tab to make the thread here. So I have to redesign the corner bracket, make the holes here bigger, and I also put some slot here to install the belt, which I will show you later because the belt installation is the last step. So for now with this, the holes are bigger, but actually with the design that I share with you, I still keep it at M5. Because if you need it to be bigger, just use your drill bit to drill them, or you just change in the design yourself. So feel free to change whatever you need to the material you have. So now I'm just going to show you quickly how to install those chips on the brackets. It's actually a bit tight, and I actually like it this way because this way the chip will kind of like stay snug inside and it's not going to move in and out. And I just going to use the hammer to tap it down a little bit like this, and also just tap it all the way in. So the holes are lined up like kind of perfectly. I don't know if I can show you here. You can see that the holes are lined up. So I only need to take some of the M8 bolt here and then just tighten it. Okay, so it actually stays like really tight here. So I don't think I need the bracket on top to reinforce it. I think this is enough. Okay guys, so after testing the tube and the corner bracket, they were good. So now the next step is just I milled out almost like all the pieces just need for the laser engraver. And one of the steps is just I need to glue some pieces together like this to have a big piece like this structure. So what I will do is just I'm going to use some wood glue like this, and I just pour on this piece. Just spread it out and press this on, and then on this put a bit and put this piece on top. It doesn't matter which way you put it, they are all symmetrical. So, and you can turn it one way or the other when you install it. So now you just need to clamp it down. Okay, so while I'm waiting for the glue to dry on the other piece, I just got to install the legs on the corner bracket. And to do that, first of all, just flip them over like this. So once I changed to the M8 board and M8 thread, I didn't realize that I reduced the space between this here and the fit that I designed at the beginning doesn't fit anymore. So what I did is just I make some of this type of spacer so they can slide in here. So just lift it up a little bit like this, and then I install the piece on top like this. So I can still keep those, and I just need to make some of this. So if you still use the M5 or M6 hole just at the original design, you don't need these pieces. So for me, I just use some of the 80mm M6 board. So I'm just going to slide through the fit. Well, I should put some of the O-ring first. Okay guys, so before putting the linear bearing setup together, I have to set up the stepper motor mount first. So it's going to be looking like this. So what you need is just use some NEMA 17 stepper motor. This plate, just you mill down, and some of the spacer for the pulley. This type of pulley is a GG2 belt, like this. It's like 2mm pitch, and you need also some gear for it. So all of this is just on AliExpress for very cheap. So what you need to do is just first of all, just take this and put it in like this. So you just have the motor mount here. So what you need to do is just take some of the M3 bolt here, 10mm length, and then use the washer and slide it through the hole here and mount it. Okay, so now the stepper motor is tightened. We need two of the M5 bolt, 28mm length. So just slide it through these two holes. Okay, and then just tighten it with the nuts. Next step, just slide on this spacer for the pulley. I have the small ring just to push the inner part of the pulley. So like this, take out two of this, slide them on, and put another spacer here and tighten it with the nut. You don't need to tighten it too much, just enough so it can the pulley still slide like freely, still can roll freely. Okay, and next step is just to install the gear on the stepper motor, just to make sure that the gear and the pulley line up. You can use the belt to test it like this. So make sure that the belt will stay kind of like in the middle of the gear space, and it line up with the pulley. Okay, so you will need like 3 of this setup. 2 is for the y-axis and 1 is for the x-axis. Okay guys, so I just going to start to assemble the linear bearing now. So first of all, I just going to start on the linear bearing for the x-axis. Okay guys, so now I have all the parts ready. So I just going to assemble the linear bearing setups. First of all, I just going to start on the linear bearing of the x-axis. So as you can see here on the side plate, I have 2 pairs. This pair have the distance between the hole a bit shorter compared to these 2. So I just going to take this one, just have the long distance here, and I take the M8 bolt 110mm length. And the reason I use those is because well, I try to find the one just have fully thread here. But the store that I went to, they didn't have it, so I had to take this one. Just a bit like have this part is not thread, but that's fine. So 110mm, just slide them through here. Okay, so next step I just take the vinyl spacer with the inner diameter is 8 millimeter. So I just slide them on here. And the length of those spacer is 20.5 millimeter, but I cut them roughly 21 millimeters. That should be fine. Okay, so the vinyl spacer is on. It just slides on some of the hard plastic spacer. Just slide it in. Like the small inner ring here should face up. Okay, now you take a skate bearing, just slide it in. Though bearing 8 by 5 by 16 millimeter, just mean you have 8 millimeter inner diameter, 16 millimeter outer diameter, and the width is 5 millimeter. Okay, now put another hard plastic spacer. Now the small ring face down to push the inner ring of the bearing. And now another hard plastic spacer face up. And another bearing. And another hard plastic spacer. And a vinyl spacer here. Okay, so now you leave it on the side and continue with the short part. This part I'm going to use the fully thread 100 millimeter length. Okay, so now I just slide them together like this. Okay, so now just need to pair up like this on this side. Okay, so now on this side I just going to lock it with the nuts. Okay, this side is roughly locked, so I just going to lock this side too. This part I will need some spacer, so I got to use this. Just I mute, so push it down. It's kind of tight, so just force it a little bit, push it a little bit. Some is easy. And then though like 19 millimeter, and then you need another 4 of 5 millimeter, because the total length is you need about 24 millimeter spacer. If you have something just is exactly 24 or 25, you can just use one piece and mill the whole way down. But I only have like 19 millimeter and 5 millimeter, so that's what I use. So on this side right now, you can just lock them temporarily with the nuts, or you can also just install the motor mount here. So this part will be the laser, and this part will be the motor here. So I just like slide it in here. So the motor is face away from the laser here, so you have more space in front. Okay, so now I can just lock it down with the nuts. Okay, so now everything is tight. We have the motor on, so it's ready to be motorized. And then this plate is to mount the laser. I already have all the holes here to mount the laser. So later on I just going to slide it on like this when it's ready to be mounted. So just like slide it on like this. And lock it with another and lock it with the nuts like this. So right now I just leave it like this. and let me just test with the tube to see it's tight. Yeah, this is really good. It's really tight, and it can well, slide still very freely, and like this, no problem, no play. So this will be good. It's ready to be installed on the x-axis. Let's move on to the y-axis. Okay, for the y-axis, it's just a bit different. Just the side plates are the same, but the type of screw will be different. I have 110mm length and 125mm length. The vinyl spacer a bit longer. They are 26mm, not 20.5. So that's it. So let me just put them together quickly. So on the long distance hole plate, just use the 110 and slide it through like I did last time. Okay, so now they are in. First of all, on this side we need some of this type of spacer again to mount the motor. And on this side, for now I probably just lock them temporarily because I don't want to put the motor on. It's a bit heavy. I will install it later. Or whatever, I just want to put the motor on. So this time, this is the upper side, so I just want to put the motor up here. I'm going to really tighten it later. On this side, what you need is just the plate, just where I'm going to slide the aluminum tube in here for the x-axis aluminum tube. So this, I'm going to just slide this on into the board. Okay, like this. It's really tight. I'm not going to tighten the board right now. I just leave it like this because I need to install the bar here for the x-axis, and then I'm going to have to slide this on and to clamp it down, clamp the tube like in between here, so it's not going to move. So I will do that later. Okay guys, so now I'm just going to slide on the bearings here on the y-axis, one on this side and one on this side. Wait, so now I'm going to have to fix this on here. Okay, just going to have to lift. Well, I probably just fix this in first. So let's just take this out, move this all the way to the back, take this out and slide it in here. Now, what I'm going to do is just install this. Okay, so now just the two pieces I just glued them together earlier. So just put like this. Okay, final step. I just want to use the nuts to bolt this down. Okay, so now to run the belt, I just go underneath the pulley, go on top the gear and go underneath again. Okay, pull it on this side. Okay, so now at the legs here, at the corner bracket, I just go underneath, pull this up, wrap it around here, and go really around here, and then try to pull it from underneath really tight, and then press it down here on top of itself, so the gear is going just lock into itself. Now I just have this piece, and I just put this like this. So now if I bolt it down underneath, it will lock here, press it down, so it's not going to move anywhere. That's how I do it on the gear on the one of the bracket. So I just do the same on the other one. It's just I need to pull it really tight. So on this end, I can do the same, but I think I feel like if I run underneath and lift this up, it's not really tight. So the belt, the tension is not really good. So what I do is just to cut a piece of the belt here. And I'm going to glue this right here in the slot here. Okay. So now I just prepare the bolts and nuts. I pull it really tight and press it down here. Okay, and I slide this through and press it down and lock it with the nuts underneath. Okay, so now the belt is tight and it doesn't move, so I can just trim this off. So I just do that for the other side of the y-axis. Okay, so now I have the belt installed on the y-axis. I just need to install it on the x-axis. Okay, so to run the belt on the x-axis, I'm just going to do the same as the y-axis here on this side. I just go loop around this and have this, and then I can pull this down and try to pull it, press it down here, and then I'm just going to slide a M6 bolt here, put in the washer, and then tighten with the nuts. On this side, I'm just going to glue the piece of like belt here. Well, now I just have to pull this real tight, real hard. Okay, last step, I'm just going to install the laser on this. Okay, now to install this laser head on this block, I just have to take this piece and probably around 8mm length should be fine. So I take this out, get some washer. Okay, so now the laser is on here. I just slide the blade in the board here and just tighten the nut and 8 nuts here, and it will be done. Okay guys, so now I'm just done building the mechanical part of this laser engraver. Everything is moved smoothly, very tight, and well, I think it will work well, but the video is kind of long enough, so I'm just going to put the next step, like the wiring of the stepper motor, the laser configuration on the control board and stuff, and also to test how this works in the next video. So look out for the second